welcome to the location tracking does scale up talk. If you don't want to hear this talk, you might be in the wrong room. Please change room if you don't want to hear it. We won't.
Okay.
The talk will be given by Aaron Kaplan. He's doing lots of work in lots of different directions. He's a member of OLPC Austria. He helps creating and maintaining the huge mesh network over Vienna called Funkfeuer, and he's with Third AT, the Austrian Third, of course, and has strayed a little from his usual paths and discovered some interesting things. Please give it up.
Thanks. Okay, so can you hear me? Okay, yeah, good. I had the great idea to come to CCC and maybe to get in. I submitted a talk and now I want to get out. But I'll try to give my best. As you already mentioned, this is not the usual stuff that I'm talking about, so this is a little bit new for me. The location tracking talk is not about RFID hacking, it's not about GSM hacking, we had a lot of that. It's not about geographic information systems or tricks that you can do with that. Actually, it's not really about hacking. This talk is more about a social issue that I want to address. And I think so far nobody addressed it yet. This talk is not about the Sputnik RFID devices that we had the last 2 years, I think it was here. It's not about breaking things, and it's not about paranoia. Because very often we get into, this thing here that, oh, we're being monitored, etc. I'm going to talk about something where we are being monitored, for sure. But the question is actually if we agree to that, and if we want to have that or not. So this talk is about triangulation, navigation in something which is probably the spectrum field. It works astonishingly well, and we all accept it, or we don't even notice it. And in keynote talk, Frank Rieger was saying we should look at this CCC where the dragons are on the map, like the unknown areas, the fields where there might be problems. So I think I sort of by accident discovered one of those, and I want to start a discussion with you, and a social discussion about if we want to have that dragon layer and if we accept it or not. So, radio waves don't stop at the window. We're used to closing the door of the microwave oven and then it sort of stops. The radio waves stop there, right? At least to some degree. 1 watt is allowed to go out, but that's not much. So if we take a look at the radio wave spectrum area, what if we could imagine if it would be just like visible light? We're all used to visible light. Visible light comes from here, from the light bulbs. It bounces off crazy, like in all directions. And from visible light, we can measure distances to the wall. We can see the refractions. We can see maybe some polarization effects. We can see colors. We can see absorption. Let's say the blue curtains absorb a lot. And light is, as we know, regular electromagnetic waves, but we're not used to seeing the other part of the spectrum. If we would be able to see the other parts of the spectrum, we would have probably a very funny, trippy time. We could see the Wi-Fi networks. We would understand them implicitly. We would understand that this doesn't stop at the door. We would understand the effects. It would be all natural for us. But since we don't see it, it's not natural. And we wouldn't, for example, be afraid of the GSM, of living below the GSM tower, because we would actually be able to see that the field, if it's not directed right down at us, it would actually go to the neighbor's window, and just below us, usually the antenna diagram would show us that the there is not much there. Yeah? And we would also understand the triangulation and distance measurement as we do with normal light. We have a feeling of how far things are with normal light, but for electromagnetic waves, we don't, in general terms, we don't understand that so well from our experience. So some time ago, like 2006, I was experimenting with a friend of mine, with Doron, about how can we visualize waves, general waves. We took acoustic for that matter, and we took simple wave calculations and created some point sources, and we're just interested where do the waves add up, and what would the contour plots be, the forms be, if we could be able to see that in a three-dimensional way. So we calculated that, put that code into the NVIDIA graphics cards, and arrived at something like this. And we even got some parts wrong in the beginning, like the near field was wrong. Anyway, it was an interesting experiment, and you know, it gives us some feeling of how it looks. The other perspective is, of course, the spectrum analyzer. This is actually taken from the Hack Center just 2 days ago. You can see channel 1 in the 2.4 gigahertz range is really highly occupied. Yeah. So, why am I saying that? If we would understand that, we would, you know, we would have a better feeling for it. On the other hand, is if we take a look at the current, just as a recap, the current, you know, physics, the current CPU's speeds, then one tick would be on a 3 gigahertz CPU would be 0.3 nanoseconds. And the light travels, just as a recap, 30 centimeters in 1 nanoseconds. So we are in that range where we can really measure with those speeds. The other way, this would be the radar ping kind of thing. The other way would be, of course, triangulation through, here are some base stations. We have been hearing a lot about GSM on this CCC, and basically, the signal-to-noise ratio can be measured at each device. We get the physics tells us the power goes by 1 over the square of the distance. If we know the original power of the signal at the source, we can again triangulate. So this is nothing new. Just wanted to recap that. Now, what happened, like some time ago, is I was updating, like many of you, to the new version of the Apple operating system, and I love Little Snitch. Who uses Little Snitch? Quite a few. For the rest of you who have a Mac, please use it. It's really, really practical. It's basically an outgoing firewall, and it will warn you of connections which you are not aware of. So in the beginning, you'll be really surprised of what your Mac is actually talking to the network. So Little Snitch warned me that in the new Mac OS X operating system, a process called Location D was trying to connect to Mac services, apple.com, on port 443 SSL. Okay, I'm curious. I took a look in Google, what is Location D? Well, it's a new service of Apple to automatically set the time zone. So when you travel a lot, you know, maybe in the US you have different time zones, you travel from East Coast to West Coast, you want your computer to automatically go to the new time zone. It's extremely, you know, practical maybe for you if you're lazy. But what really happens is that Apple actually gets the BSSIDs, the Wi-Fi networks in the area, sends it, you know, the location D sends it to Apple, and will ask Apple, where am I? In which time zone? Actually, which latitude, longitude? And this database source is very accurate. Now, if we take a look at the small print of this advertisement, location information depends on data collected by third parties. These data services are subject to change and may